The focus of this lesson is on solving polynomial inequalities using test points. So your first step that you would do is you would move all of the terms of your polynomial over to one side of the inequality so that there's 0 left on the other side. And that step is already done for us in the inequality that we have. So then what you would do from there is you would factor the one side of your inequality and determine the boundary points after you factor. So I just reordered my terms from highest degree to lowest power just because it's easier for me to factor that way. If I have a leading negative coefficient, a lot of times I just divide that out or divide that off. And when you do that, that will change the order of your inequality symbol, because whenever you divide off a negative, the symbol needs to change to account for that division by that negative on both sides of the inequality. So I've done that, and now I can see that I have a difference of squares. So this one factors x times x gives us that x squared, and positive 5 and negative 5 give us that negative 25. And then outside inside will cancel out, and so this is the factorization. You could FOIL it to check. And then in order to get the boundary points, we're going to set each factor equal to 0 and solve. And when we do that, those values are where our inequality would be equal to 0. Now, we are not concerned with those values being solutions in our particular problem just because our solutions are all those values greater than 0. So we will have either an open circle on our graph or parenthesis in our inequality or interval when we talk about our solution set, because we will not include negative 5 or 5 because this is where we're equal to 0 and not where we're greater than 0, and we're only concerned about where we're solely greater. So then what you would do is you would draw these boundary points on a number line, so negative 5 and 5. And then what you would do is you would pick test points within each interval. So I already did that in this graph here. You can kind of see in this table. But some test points in this first interval, it goes from negative infinity to negative 5. So negative 6 would be a good test point. And then between negative 5 and 5, 0 would be a good test point. And between 5 and infinity, 6 is a good test point. And so I would use these as tests in my factorization of our inequality to see if they are solutions. And if one of them is a solution, then the entire interval is a solution. Okay, and so you can see again my intervals go from negative infinity to negative 5 to 5, and 5 to infinity because of how they're broken up by these boundary points. So I'm going to go ahead and test negative 6 first into my factorization, which is x plus 5 times x minus 5, or vice versa. But when you plug in negative 6 for this first factor here, you're going to get a negative. If you plug in negative 6 for the x plus 5, you'll get negative 6 plus 5, which is also a negative. And so that's a negative times a negative, which means your sign is overall positive. If you plug in 0 as your test point, 0 minus 5 is negative. 0 plus 5 is positive. Multiply those two sign factors together, you'll be negative overall. And then last but not least, do the test point of 6. Plug it in. 6 minus 5 is a positive 1. And 6 plus 5 is a positive 11. So positive times a positive is overall positive. Well, we're concerned with this inequality right here, which says we want our solution to be greater than 0. So that means our solution would include all of the positive pieces. So the intervals on which we are positive is from negative infinity to negative 5, not including negative 5 because that's where we equal 0 and we don't want that, union 5 to infinity, and again don't include the 5, so use an open parenthesis to represent it because that's where we're equal to 0, and we're not concerned about where we're equal to 0, we're only concerned about where we're greater than 0. So this inequality, or this interval, represents our solution overall for this particular polynomial inequality.